Hello everyone and welcome to another lesson. Professor Mab here. The topic of today's lesson is design factor and factor of safety. This topic is part of the following courses: machine element, design and a strength of materials. In order to talk about design factor and factor of safety, we first need to discuss the concepts of a strength and a stress. Strength is an inherent property of materials. It depends on the material's treatment during the manufacturing process, and it may or may not be uniform throughout the entire part. Some examples are ultimate and yield strength. Stress is a state property that is specific within a point in a component. It depends on the loading and the geometry of the component. Different loads applied to different parts of the same component result in various amount and type of stress. Some examples are normal and shear stress. Different types of strength and stress are discussed in other videos in this channel in detail, but for now, we use this introductory information to build our case around design factor and factor of safety. The design factor is defined as the following ratio. In the context of mechanical design, a component will lose its functionality when the stress applied on that component exceeds the component's strength. So the design factor could be written as the ratio of strength to stress. Using this definition, can categorize the design scenarios into two groups: safe design versus failed design. A safe design is a scenario where the component's strength is larger than the applied stress, which means that the component can withstand the stress safely. This scenario is associated with a design factor of larger than 1, as you can see from this equation. On the other hand, if the component's strength is smaller than the applied stress, the component will fail, resulting in a design factor of smaller than 1. An important note here is that the value of 1 is a theoretical minimum value for a safe design. In reality, a larger design factor is prescribed based on several factors, including the application of the component, the uncertainty in the component's strength, and other operational conditions. For different components, different design factors are either recommended by relevant industry guidelines or mandated by regulatory codes. For example, the design factor for a rod in regular applications could be as small as 1.3, while for a traction elevator, a large design factor of 12 may be used due to the critical life and death nature of its application. Another important point about the design factor formula is different design theories use various strength and stress in this formula. So while this formula is used in this lesson to demonstrate the concept of design factor, other important design theories are discussed in different lessons in this channel. Now let's talk about factor of safety and its difference with design factor. So factor of safety, or N, is the actual design factor after the design is completed. The design is considered complete when the final size of a component is selected, usually based on the available standard sizes offered by the manufacturers. See, in real design scenarios, you often end up with a size that is not available by the manufacturers. So you need to go one size larger. That would change the value of your design factor to a higher value. This value is our factor of safety. In other words, the factor of safety is the realized design factor, and it is always larger than the design factor. Thanks for paying attention to this lesson. Please let me know if you have any questions.